Right, so now let's come to maths for ages 6 to 8 and 9, and then also the play aspect can also go for preschool. That is those the 2 years to 5 years, okay, and then the lower primary where we have the 6 to 8 or 9 years. All right. So first of all, we'll look at the numbers. So the numbers. So what we are doing is here, and the same thing is when we are looking at numbers. We always talk about the play form, then we come to the sketching. Okay, that is all that we are doing. Sketching. Sketching is very important. So drawing. Okay, as we keep on doing that, it will be sticking. Right. So numbers you can have so many. So they usually start counting from 1, 2, 3, 4, 5, so on. Then they can start from 0, 1, 2, 3, 4, 5, so on. Then you can start from where? The negative, sometimes you can have the number like 0, you can have 1, 1, 2, 3, 4, yeah, negative 1, negative 2, negative 3, and so on. Okay? So sometimes you can have fractions in here. So fraction, let's say negative 2 over 1 over 4. Let's say 1 over 2. Okay? So at other times we may have decimals. Okay? We can have decimal here, maybe 0.6. Then we can have one that will not, the decimals will never be ended. Maybe we can't put it on another 0.6768. Maybe you can have one here. Maybe you can put it here. 0.2525 and so on. But this one we can't put it in there. 671012459. This is going on and on. Okay? So this is the kind of numbers that we can have. Then sometimes you can have a number, maybe square root of negative 4. What is the answer going to be? Okay, so when you have this concept there, so these are the numbers. So you can let them play around numbers. Okay, you don't need to tell them what they mean. I mean, just let them try to count from 1, count from 0. You have this pen, the number line, okay, shown to them. You can also have the graph too, okay. You can have 1. I'll do that. Just introduce them to graph 1, okay. So here is 0, 1, 2, 3, 1, 2, 3, 4, negative 1, negative 1. Okay, so you can let them write this one, write that one, recite, so on. So let them play around this one. So they write this one, write this, do this. That is sketching aspect. In playing, you can let them have the numbers. Okay. When it comes to negative, let it be like we have taken away. So you take away from them, then that will be like negative, or owing. Okay. So that kind of thing, that negative thing will be impacted. Okay. So that if you take something away, it is negative. If you owe, it's negative. Those kind of things can be impacted. So you can look at it that way. So of course, by doing this, then we are looking at the natural numbers, or counting numbers. Okay. So this one you have the whole numbers you are looking at. Okay. This is integers you are looking at. Right. Then under that you can have what you call the 2, 3, 5. These numbers you can't divide them. Okay. So let's go to the 11. So these numbers they cannot be divided, or you don't have any number dividing them. So you are looking at the prime numbers. So okay. Right. So you can have all those ones coming into the picture. Then the fractions, those coming in fraction. Fraction is the same as fraction. The fraction is to sort of get it into fractions. Okay. So they are called the rational numbers. Okay. They are the rational numbers. Now there are numbers that we can't express in fractions. So these ones they end. See that here is 25, 25, 25, 25, 25, 25. After a number we don't say 25. We mention the numbers 1, 1, 1. So 25, 25, 25. This repeating. So this one somehow can be represented. Okay. So So this is kind of this one ends can be represented. Okay, so they are under the irrational number. But there are some fractions which will never end. To keep on going, it will never end. Okay, so there will be irrational. Irrational numbers. Okay, they can be in a form of fraction too. Maybe have any fraction that you can divide, you will never get to an end. Okay, right. But remember fractions, if I write 5 over 2 is the same as what 5 divided by 2. Okay, 5 divided by 2, you can use it. So 2 will go into 5, 2, which is 4, you subtract, get 1. Okay, then add 0 to 8, 2 going to 10, what? 5. Okay, but of course, put your decimal there. And that will be 10, that will be okay. You always, once you get 1 is less than 2, so you put decimal there, and then come and add 0 to it. So that one is there. So it's like all fractions can be expressed in the form of decimals. Okay, decimal is most last in the 10 in the 0.4. Okay, but this one you can't express it as a fraction. It is never ending, so it is irrational. A means not. Okay, rational. There is rational numbers, so they are not rational. It's irrational. Now the other aspect of numbers. For example, this one you can't find the answer. Square root of -4. Square root of 4 is 2. But what is the square root of -4? It's complex. This is complex. We can't do it at this level, so we say it's a complex number. Okay. Now remember that there's a last part I want to add. Square root of the prime numbers. The prime numbers. Okay. We call that sets. Okay. We call that sets. Okay. So when you have square root of, let's say 2, you can treat it as a set. Right. So that is under numbers. Then these sets can be treated like letters like x, y, and so on. Okay. So this is an aspect for numbers. So I'm just giving a picture. As an assistant, you take them one after the other. You don't go like this, you take them one after the other. And then you go in that order. The next thing that we come into will be algebra. So when we come to algebra, we are using letters. Letters, okay, to represent numbers, okay. So I can say x, so that I can say 2, I say x plus y is equal to 2. So this one, I'm looking at algebra, okay. So we have two different, these are representing numbers, but I don't know what number it is I'm putting in there. X plus 2 is equal to what? 5. These are algebra, okay, so that is it. Sometimes we can have the algebra as just single one. To the power, this one is x alone. There's no x to the power 2, x to the power 3. So x to the power 1 alone. So this is more or less what I'll put here as linear. Okay, sort of linear equation. Okay. Now sometimes instead of having x to the power 1, you can have x to the power 2. If the x to the power 2 is the highest, then we call that quadratic equation. Okay. Sometimes we can get beyond x to the power 2, x to the power 3, and so on. Then we call that polynomial. Okay, they are all representing numbers. Okay. So this is the point that we want you to note. So we have algebra, and that we have so many. So letters representing numbers, okay, will fall under algebra. Right. So different types. The linear equation will say y is equal to mx plus c. We'll come to this later on. So we can say y is equal to 2x plus 5. Okay. This one, if you put any figure here for y, for x, you get another figure for y. So where x can take several numbers and y can take corresponding several numbers, we call that function. So it's like mapping. Okay? But where x is equal to, well, the letter is equal to one number, or a fixed number of numbers, then we call that equation. So let's say 2x plus 1 is equal to 5. This is equation. This is equation. This is function. Okay? But this, we don't need, we'll come to it later. Just a brief question about functions and then equations. Okay, just something small. Maybe when we go back, we'll talk about it. But understand that algebra, we are using letters to represent numbers. So you can see, you can first let them start like that. Let's say you have 2 things here plus this, okay? Maybe something like that. I'll make it this way. what will enter in. So here, okay. So this is 3, this is 2, the answer is 5. Then you can say, okay, let me put X here. So this is 1, 2, 3. This we don't know, this is 5. So what will X be? So what you do is then you can just let them introduce what they call, you let X cross the equal sign. Anything that crosses the equal sign becomes the opposite. So here 5 is there already. 3 is coming. 3 is, if there's nothing before you, it means you are positive. So 3 is positive. When it crosses and comes here, it becomes negative 3. So 5 minus 3 has to be equal to 2. 5 minus 3 is 2. So that is 2. So this kind of thing, you can start like that. So here we allow the letter to represent what we are talking about. So see that this and this, they are the same. That is why we are able to add them. Okay? But if we are adding something like this, you can't say this is X and this is X. You can say this is X, maybe this is Y. So see that they are not the same, so we can't add them. This one, you can't say it is 5. Let's say this is orange. And these are sticks, okay? You can't say it's 5 oranges, 5 sticks. You can't say anything. But if this was, this is orange and this is also orange. If you put them together, then you can say what, 5 oranges. So when they are not the same, you can't add them. So when it is X and Y, you can't add them and get one answer. Okay? That thing should be there. Right, so we are building up. So that is under algebra. So we are saying that the equal sign, if you are negative and you cross the equal sign, you become positive. If you are positive and you cross the equal sign, you become negative. If you are dividing and you cross the equal sign, you become times. If you are times and you cross the equal sign, you become multiplied. So this is very important thing to have. Okay? Because, so let's say negative 2 crosses, it becomes what? Positive 2. Positive 2 crosses, it becomes what? Negative 2. So that's what I say. So let's say it's 1 over y is dividing here. When it crosses, it's dividing. So when it crosses, it will be multiplying. It will be multiplying. Okay? That's what we are saying. But let's say divided by y. It crosses, it becomes what? Times y. If this times y, it crosses, it becomes what? Divided by y. Okay? So that is how it is. Okay? So note when you cross the equal sign or something. Sometimes the equal sign, instead of being equal sign, we are going to call, this is what your less than, this is your greater than. This is your less than or equal to, greater than or equal to. Okay? So always this one opens, the mouth of this opens towards the bigger fish. Let's say I have this, and this it will open like that. If I turn it, so this is a fish, it will always eat the bigger one. Okay? So if I turn it like that, where will you draw the fish? So the fish will not open like this. So the fish will eat the bigger one. So there is the sign goes to the bigger one. Right? That helps you to get it well. Okay, so that is that for equal sign greater than. The same thing can happen to the, when it comes to let's say it is greater than, negative crosses becomes positive, positive crosses becomes negative. If dividing, okay, let's say let me make it clear. So if positive, let's say positive. So positive, it crosses. Now it is going to be this. It's going to be this, and then we're going to turn the sign because it's going to be negative. We are going to turn it and make this positive. Right? So it's not just straight away. Sorry for the first one. So this is crossing. It will cross. It will become the opposite. Of course, you have to turn the sign. Okay. Same thing. So if it's here, it turns becomes negative here. Okay. So that's negative. If you are dividing, that is okay. If you are dividing, it's the same thing. That one doesn't change. Okay. So it becomes what? Times. If you are multiplying, it becomes sorry. If you are multiplying, it becomes what? Divided. Okay. But the same thing. This can also go for the same greater than. The same thing can happen to greater than. So this becomes less than, and then it becomes positive. If it's positive, then it crosses. it becomes what? Less than, it becomes negative. So note, it is when it comes to this one, the sign turns. If it is plus and minus, the sign turns and then get the opposite one. Right. So let's say if I have x minus 2 greater than y, then it becomes x. I'm sending this one across. It becomes, we'll calculate y. This is plus minus 2 becomes plus 2. But remember, this sign has changed. Okay. Okay, so this will go. And this is what we are seeing. It's negative, it becomes positive. If it were the equal sign, the equal sign will still be the same. But because it is greater than or equal to, it will change, the sign will change. Right. That is how it is. So you can look at it. Let's say we said x minus 2 is equal to y. This is greater than y. Let's say this one is y is 1. Then this should be 4. Okay, x is 4. And that. Now let's see if we have x, this one cosine. Then we have y plus 2. Okay, x, this is going to be, we are saying 1, so it's going to be 1 plus this is going to be 3. Okay, so 3 will then be what? Less than, so we have to 10. That is why the equal sign turns. So this is proving why this equal sign is 10. So this one crosses. If this is 2, it becomes plus 2. Okay, and then we say 1. This is going to be less 3. 3 will become less than x. That is why the equal sign changes. Okay, right. So this is a simple way to prove why it will change. Right. So this part is also important. Get the concept. You can let them go through a lot of exercises and know how to get this. So the factor tree is very important. Let's see, 10. Factor tree. Okay. So 10, you find two numbers which one you multiply, get 10. So you can start with maybe 2 times 5. Okay, so the factor tree for 10 is equal to 2 times 5. Now let me make it 20. 20 I can have what? 2 times 10. Then 10 I can have what? 2 times 5. Okay? When you can divide any of them, then these ones become the factors. Call them the prime factors. The prime factors of 20. So 20 will be equal to 2 times 2 times 5. 2, they are the same, so you can write them to the power. When they are the same, you can write them to the power of. So to the power means this, you can write 2, they are 2, so 2 to the power 2 times 5. Okay, so this is what you call the power. And these ones, when you do that, we are saying you are writing them in indices form. Okay, right. Right, so that is how. So you can use prime factors to find. So let's say I can be given 10 and you have to find the set of what the numbers that can divide 10. Okay, so factors for 10. So I know 1 can go in. Now 1 is a factor for every number. 1 and 10 itself. 2 can go in. 5 can go in. 10. Okay, so you can use the factor tree. If you use the factor tree, 2 and 5. So 2 and 5 is it. And then always 1 in the number itself will be part of it. You can have multiples of 10. Multiples of 10 will be when you multiply is the 10 times 2, 10 times 10, 10 times 2, 20, 10, 3, and so on. Okay? So there's a set sign. Okay? Set sign. Okay? So there's a set of, these are the members or elements. Members or elements. Okay? Right. On to geometry. So you can look at geometry. Okay, so we can have a triangle, we can have a square, we have a rectangle, we have a kite, rhombus, okay, we have a trapezium, and so on. Okay, so the various shapes, you let them go through. Then I have a circle. So these are the plane figures. Then you can have the solids. Okay, so the solids. There is a cylinder. Okay, this is a sphere like ball. Right. So these are plots. So there is a prism. Prism. Okay. Some can be different forms. I put them there. So these shapes you must let them know or learn them. Okay. Now let's focus on triangles and then circles. Usually you can have a straight line, right? The angles on the straight line will add up to 180. Okay. Now you can have this one, these two lines, they are going the same way, they are never meeting. Okay. They are in the same distance apart, so we say they are parallel. Parallel. Okay. So we use this one to show. So this is an angle. This is an angle. The distance between two lines. Okay. This angle, they are the same, they are alternating angles. Right? Okay, these are interior opposite angles. Okay, they add up. Right. So these are the things. Now we can have a triangle which can have one of the sides being rectangle. That means being 90 degrees. Okay, so this is a right angle triangle. Right angle triangle. Okay. Now when it comes to this one, we have what we call Pythagoras theorem. We say that, let's say if this one is height, this is hypotenuse, this is hypotenuse, this is height, this is hypotenuse, this is base, then hypotenuse squared is equal to height squared plus base squared. Pythagoras theorem. Okay, that's one. We can also relate the angles. Let's say this angle A, this angle B. Okay, we have what we call the angles. We can use. This is angle A, angle B. Okay, and this is right angle. Now what we call so okay, which says that sine. So means sine of the angle A. Let's say sine A is equal to opposite over hypotenuse. So it means opposite. Opposite is, if this is A, opposite, the angle facing it is opposite. So this is opposite, okay? So this length, you put this length, let's say this length is H, and this capital H, this is B. So it means it's what? Small h over what? Capital H is equal to this angle sine the angle greater than that. Okay? This angle is in degrees, okay? Right. Okay? Right, so we find it in degrees. So that is that. If it is K means cos, so that is cos A is equal to what? This means adjacent over hypotenuse. Adjacent over hypotenuse. Okay? Adjacent is what? B. The line that is close. Adjacent means close. B is close. So B over what? Hypotenuse, capital H. Then at the last one, toi. Toi means tan. So it's a tangent. Tan is equal to tan A is equal to what? Opposite. Opposite is H over hypotenuse. Sorry, over adjacent B. Okay, so these ones you must note here. Right, so this is just an introduction. You can play around this. This one is just for the lower. I mean, the introduction is just by then you solve that one. Just opposite over this. With time, when they come up, we'll be able to build them up from there. Right, so they can have the sketch. You can have the play, and then you have the play tools for these ones, right? So we can sketch, can get the angles, you can let them draw, try to sketch, and then have these ones. And this cannot be done. They can do it with a needle back. They can have the play tools around, where we have a line, we let them be in a line or draw a line, get something in the form of a triangle, and then change the forms. Okay? Right, so the different types of triangle too are there, where we have equal sides throughout equilateral triangle. We have two sides being equal isosceles triangle. Okay, then none of the sides being equal. Okay, none of the sides being equal is a scaling triangle. Okay, so these are there that you can let them look at. So this is just to bring the picture. And of course, you must let them know area of all these, the formula for area. we have already described that. Let's put it there. So for a triangle, area is equal to what? Half base times height. For the circle, area is equal to pi r squared. These two are the most important part, because if it's a right angle, area is equal to length times breadth. If it's a square, it becomes side times side, okay? Something like that, okay? Right, so when it comes to volume, what you do is volume is always equal to the cross-sectional area times length. Okay, so if I have this, I want to get my volume. The cross section is, you look at the shape of the cross section, which is a circle. So it means it's a circle, area of circle times the length. The length is this one. This is the length or height. It can be length or height, the same thing. Length. Okay, so this is a cylinder. This is a cylinder. So its area will be equal to what? Area of the circle, which is pi r squared, times the length or height. Some say height. So this will be the volume. Okay? And volume must always come with a unit to the power 3. Area must come with a unit to the power 2. So let's say centimeters cube. This will be centimeters squared. This will be centimeters cube. Area squared. Volume cube. Okay? Raise to the power 3. Raise to the power 2 for area. So this is how you can build it. So you can have something like this. Maybe a kite and thing. So what is going to happen is the cross-sectional area, this cross-sectional area times this. So we know the cross-sectional area can easily multiply that. Okay? Right, so that is that. Okay. Now let's look at sequences and series. So I can have 1, 3, 5, 7. And when I start like this, you can tell me what is going to be the next. You say 9, 11, and so on. So this is sequence, okay? And how did you get to know that it will be 9? You realize that I was adding 2. So when you're adding the same number, or using a certain number to get the next one, then you know you're adding with sequence, okay? Right. So you can have what you call the AP, or arithmetic sequence or progression. This one is just, you add the same number, Sometimes instead of adding, you rather multiply. When you are multiplying, that becomes geometric progression. Okay, geometric. So if you are adding or subtracting, that is arithmetic progression. If you are multiplying or dividing, then depending on how you are looking at it, then you have geometric progression. Okay. So here I can have 2. So this I was adding. I can also have this 2, 4, 8, 16. So you realize here I'm multiplying by 2. Here multiplied by 2. So here I was adding 2, multiplying by 2, multiply this by 2. I'm multiplying by 2, here multiplying. So because I'm multiplying, this becomes geometric progression. Because I'm adding or subtracting, it becomes arithmetic progression. Right. Progression. Okay, so this is just introduction to that. So you can let them try numbers. You can start 1, 5, let them go 9. So let them continue, then they try to get the sequence for you. Now, when it comes to geometric, you can let them multiply, then you do the play with it. The series, we are looking at the summation, how we are summing them. Okay, so let's say if I add the first two, 1, 3, 1 plus 3 plus 5. When I'm doing this, when I'm adding them, that is summing them or adding them, then I'm talking about series. Okay? So once I know AP, I know my AP, we can put them together, subtract them. Sometimes we have a third one that we call that one. You look at your number before. So number before. So let's say if I have 2, I do something to 2 to get the next number 5. I do something to 5 to get the next number, let's say 8, I do something to 8 to get the next number, okay, then that one is different. So that one is kind of with the progression that we'll look at later, but something like this is also there. So get the AP and GP, then there's something like that also, where you look at the number before you go to the next one, okay? Right. So that in that case, you can have something called Tn plus 1. Here we just have Tn, n is representing the position of the AP or GP number, okay? So this is the third one where you have something like that. So here, to go to the next number, maybe you're adding, to go to the next term, let's go into the next term, okay? You have to do something to the previous number. So here you only look at the previous number to deal with, but here it starts from the first one and it goes that way. Right. Now let's look at the calculus aspect, how we're going to get them to get the basis so that as they grow they can be able to imbibe what we teach. So here what we do is that we can have something like this here. And ask them to calculate this area. Here we have this, here we have that, here we have that. Okay, so if we ask them to calculate this area, this whole area, how are they going to calculate it? Okay, so you see that they can say, okay, in this one we can find the area for this one. We can find the area for this one. We can find the area for this one. Okay, this is a triangle. This is a triangle, so we can add it, almost a triangle. This is almost a triangle, we can add it. So if we know the area, this area is what height, this, let's say this, okay? So h times b, okay, this will also be another h times b, okay? Another h times b, okay? Then when you finish, we add the triangles, okay? Triangle is half base times height. So it's like you can do something to get the area, okay? And the same thing is what comes to. So we can, this one is giving them the picture of adding small bits. So we are adding small. So if I give you something like this, and I say find the area, what you can do is you can just make it triangles, very small triangles. Okay, very small triangles, and add it. So by adding them very small, it's more or less what we call integration. Okay? So it means you can integrate over this one will have this line will have an equation or a function kind of thing. Okay? So this line will have an equation or function kind of thing. So if we know it and then we can be adding like this, we can deal with something called integration. So we can add it. In the same way, if you want to find the, we know this one, the slope is like this. If you want to find slope, slope is what? The change y over